about this ellipses. And if you had any problems for me to do, please let me know. I will start with those. And I'll just select and do an exercise. So last time we learned how to find the center of the ellipse. So we had a formula x subtract h squared over a to the second plus y subtract k squared over b to the second. And the key idea was that we needed to have number 1 on the right side. So then you get an ellipse. If you don't have 1, then you need to produce 1. So let me do an exercise then. Maybe the problem like number 49 to start. To produce this formula above out of equation with 2x squared and 3 times y squared. And there's also x term and y term there, minus 8x and plus 6y. Okay. It needs to be rearranged, right? Because x's should be together with x and y terms with y's. And of course, prepared for us to complete square twice, once on the x terms and the other on the y terms. So I'm going to take these two terms with x and prepare it by factoring out 2. So x to the second will be here minus 4 times x. And then I'll leave a little room here and then also take a look at y terms, 3 and 6. So I'm gonna factor out number 3 because I need to have always clean x squared or y squared in my parentheses. So I can do the process of completing squares. And I can take that 5 away on the other side. I'll just put minus 5. So it doesn't participate in the completing squares process anyways. So now I'm going to need to divide number 4 by 2. So that's going to be a 2, which is squared, gives me 4. And I add and then I subtract the same exact number 4. That's the key part of this procedure. Analogously with y, I'm going to divide it by 2. That number 2 is y, so I'll get a 1. So I'm going to add 1 squared, which is just a 1, and then subtract it. And this enables me to complete squares. And that's what we've been doing all the time so far in this class. So x is the first.
I'm a little bit confused. I don't understand where you got number 4, like the 4 from.
If you add 4 to number 2, then you have to also subtract 4. So this way you're not going to change anything.
Yeah, but you took 2x and you separate 2x to the square plus 3y to the square, and you separated that and you put 2x open parenthesis x squared minus 4x. But I don't understand how you got that 4x. Where did you get it from?
How I got 4x. So this
Mhm.
is 8. And if I factor out 2, then 2 times negative 4x is same as 8. So when I take out 2, negative 4x stays. Is that the question? Where 4x is? Well, distribute back 2 and you get back your 8x with negative sign. So always take out the number which is in front of x squared term. And the same thing with y squared. So I had
Also, to
3.
separate the number from the symbol, you have to change it, but it's still the same thing because you can multiply it and it'll become 8x, negative 8x.
Yes, because it's the same thing. I cannot change anything in my equation. I just need to prepare it to complete square. So I factor it out, but I can't all of a sudden write something else because it's not going to be the same thing. So
Okay, I understand now. Thank you.
keep it unchanged. Okay, good. So looks like first term is x, last term is 2, and the minus in the parentheses, square is completed for these three terms, and same for the other three. Y, the first term, last is 1, and the sign is positive. So y plus 1 squared. So this way I started, and now we're going to copy the rest without a change. So 2 here, there is still minus 4 in there, right? And there is plus 3, and again a big parentheses, and there is minus 1. So it's very tedious, but the good thing, it's same procedure for all exercises. So I guess if you go through this once and then you go through it once again, and in the next section we're going to do this again, then eventually you will feel more and more comfortable. So it's good to pay attention to all these details. And that's what you are doing, and that's great. That's the way to go. So now I need to bring that 2 back in. So I distribute it and multiply it back by parentheses and by negative 4. And the same with 3. So I multiply it by this y plus 1 in the parentheses and by the other piece here, which is negative 1. So I get minus 3. Okay, so this is equal to negative 5. And we have prepared to produce number 1 now on the other side, because what we have to do is bring this numbers 8. So it'll be plus 8, right? Here on the right. And also 3. So it'd be plus 3 then on the right side. So now we're going to be producing this number 1 on the right side. So I already have coordinates of center. So just need to prepare my right side. So I just leave x parentheses and parentheses with y here on the left. And number, let's see, 3 and 3, 6 looks like, right? Will be on the right side. Great. So we have almost done with this. We just need to divide by 6, right? Each entry of this equation I divide by 6. Again, the reason I do this is to produce 1. And what we left with is going to be 3 here on the bottom and 2 underneath y term. So our equation now is going to look like x minus 2 squared divided by 3, right? And also y plus 1 in the parentheses squared, and this is divided by 2. And of
Professor,
course, yes,
the minus 8 from the negative 8.
negative 8, yes.
Yeah,
When you
but you,
multiply 2 by negative 4, you get
oh, okay.
negative 8. And the same exact thing you get here when you multiply 3 by minus 1. It'll be 3 times negative 1. It's negative 3. So you distribute. So now what? Now I need to have those squares on the bottom. And there is a standard little trick. You extract square root and then square. If you can extract square root, you do this. If you can't, well, just leave it the way it is. So this way I see that my a is a radical 3. My b is under y radical 2. And the center of this ellipse will be, let me write it here, center is a pair with coordinates 2 and -1. So we'll always change signs inside this parentheses, and if you want, you can make a picture of this. Let me do that. So 2 -1, the point is here. And now I need to go left and right by square root 3, which is about 1.7. If you extract square root, you can use calculator. And analogously with a square root 2, it's about 1.4. So I need this to better see how the ellipse is located with respect to those x's. So it's point. So if you go to the left by 1.7, you're not gonna reach the x's, and to the right. And upwards by 1.4, you're gonna cross the x's. So now I can try to put the picture. So it's similar to the circle somehow, because the A and B are pretty close to each other, 1.7, 1.4, but it is still not a circle, still a little bit contracted from the top and the bottom, squeezed a little bit. So in this section, I'll be just concerned with this ellipse work, and I graphed a few of them last time, and we just did another one. And the whole point is to produce its center and to follow to that procedure. It turns out that very, very similar formula appears when you are dealing with the other curve called hyperbola. And instead of plus sign, it has a minus in between of x and y squared terms. And it's still number 1 on the right side. So this hyperbola process is just analogous to producing the ellipse. And that's why the sections follow one another. And here's the actual general formula that you can find here, which is very, very similar to the ellipse, but it has a negative sign in between. So I'm gonna copy this formula and I'm gonna utilize it again, x minus h. So center is always called h and k, even though formula looks not very nice, right? But if you look closer at it, it's gonna be just like formula for the ellipse, but instead of plus sign, so I just copied what we used to have here, but now instead of plus sign, they use minus sign, and that's the only thing that they utilize. So when they be graphing this, like in figure 42, they put center, then they put this A here and B here, but instead of ellipse, they do something else. Since it's a minus, then they have to put a box instead of ellipse. And then diagonals of this box will be so-called asymptotes for hyperbola. In fact, you already learned once how to graph hyperbola 1 over x. Do you remember this kind of curve? It has two asymptotes and it approaches to the x-axis and to the y-axis somehow like that. So it looks like it is similar to figure 42, but if you rotate it by like 45 degrees or so, right, then you're gonna produce analog of this 1 over x. So let me repeat the completing of squares procedure once again for this section. See, it's very heavily utilized in every pretty much exercise in these sections, this completing of squares, and that's why I'm concentrating on it so heavily, because problems where you already have something that fits into the formula are pretty straightforward, but if you don't have this parentheses with x minus or x plus, like we have here in the next section, so on page 696, and what is this section number? Let me check. 10.4, section 10.4. So analogous group of exercises to what we just did is here. So in section 10.4. And deals with these hyperbola graphics. So let me, well, just do one for you. Let me try number 55. So I'll do another graphing of this. I don't want to spend all the time on this completing squares, but as much as we need, I guess I have to. So I'll do one more, and then next time we'll do another one. So keep on completing these squares. So I'm rearranging. I'm going to put x with the x squared term next to it. And then I'm going to need to put a little bit of a room. And then y squared, actually. Let me just copy minus y squared, and what else is here? Minus 2y and minus 1. Okay, I just copied this, rearranged x's and y's, but now I need to prepare to complete square in here. So my x to the second minus 2x are fine. I could just take a half of 2, which is 1, and add it and subtract. But with the other piece, I need to take out negative, and then have x squared or y squared plus, say I change sign, plus 2y. And then I can also bring that number 1 over to the other side, so it's on the right side. So let's start. Half of 2 is 1, so I add and subtract number 1 squared, so I add and subtract number 1. So these three terms will be giving me that parentheses squared. Same with the other. So now it's a plus 2. So again, I divide it by 2, I get 1. So I add and subtract 1 squared. Always add and subtract exactly the same number, right? So we now have another piece. So they be parentheses x and minus 1. In the first parentheses, we have a minus. And in the second parentheses, there is no minus. Everything is positive, so it will be y plus 1. And I put squared. So because of this, we had to go through this process of factoring minus 1 out and so forth. So copy the rest. There's minus 1 here. There is a minus sign. There is a big green parentheses with a minus 1 in it as well. And copy 1 the way it is. Now what? Well, now looks like I need to distribute this negative back. So I need to write minus in front of y plus 1 to the second. And then minus times minus will be plus, right? Plus 1. And it's still equal to 1. And copy whatever we had here in the beginning. And looks like now we cancel this plus and minus 1. And that's great. I love to cancel. So we already have equation of hyperbola. At least we can clearly see what the center of it is. So x minus 1 squared. And the other piece is, see, negative is in front of the other piece. Negative is in front of my y squared. And 1 on the right side is just what I need. And I will also produce these a squared and b squared on the bottom? By, well, you can put 1. Divide by 1 means nothing, so I put 1 squared, the same as 1. So it turns out if there is no denominator, it means it's 1. So my a is 1, my b is also 1. And the center, I just need to change signs. Inside this parentheses will be +1 for x and -1 for y. And now the question is, how can I graph this hyperbola? Well, the procedure is here. So you have this center, 0.11. Now I need to use actually 0.1 and -1. I should be careful. See, if you relax a little bit, right away, there's a little mistake coming. So concentrate. So we have this point, right? +1 and -1 for y. And then a and b are the same, and they both equal to number 1. So for a, go by 1 to the left and to the right. And by b, I also go by 1 up and down. And this enables me to, instead of producing ellipse, because we have here minus sign, to produce a box. So just get like a box here. And then in this box, I'm gonna have to produce diagonals of this box. See, there's a little bit trickier to construct it. But I'm sure if you construct a couple of hyperbolas, you will start to feel better. And now I'm gonna look at the pictures here and notice that we have sometimes, like in 37 and 38, in this box, hyperbolas on the left side and on the right side of the box, but it may also be on the top and on the bottom, like here. So which way should we make a picture? Well, here's what they're saying. If you have positive x squared or positive y squared. So in our case, we are dealing with situation where our x squared is positive, right? Because if x squared is negative, hyperbola is on the top and the bottom. But if it's positive in front of x squared, like the one we have here, positive in front of x squared, then the hyperbola is on the left and on the right. So what we do is put left and right. So it depends if x squared is positive or not. Because notice that your term with x squared may be negative. So you may have negative in front of this x minus h over a squared. And now it's going to be plus in front of y squared, y minus k over b squared. So if that's the case, you get top and the bottom. And that's actually what they're trying to describe in here. So where's this? See, with formulas is a little bit more tedious, because when you're looking at these formulas, you probably not have a very clear feelings. But if you look at these two pictures, pictures give a better intuition. So they tell you if your y is negative, right, then it's left and right. And that's what we just graphed. But if your y term is positive, so x is negative. I wrote negative in front of x on purpose so you could see that the signs changed. So then y is going to be positive. But of course, you can put y term in front. That's what they actually do here. Then the hyperbola is on the top and the bottom. That's how it works. And well, I guess there's top and the bottom and left and right is the last thing I want to discuss here in this section. So let me go to some exercises in the beginning of this story so you can actually pull out some of these hyperbolas, like in exercise 29 and so forth. Maybe I'll do 31. 31 is recommended problem. Moreover, 31 needs a little bit of preparation because it does not have number 1 on the right side. You see that? So let me do 31 exercise for you. 31 because 4 with x squared minus y squared, which is equal to 16. 16 so should not be there. And that's fine. We can take it away. We can divide by 16 because we always need number 1. So I'm dividing by 16 each piece here. So nothing changes because we did same thing on both sides of equation, but we produced 1, and that's just what we have to produce. So this will be 4, and instead of 4 in denominator, I can write it as a 2 to the second power, right? Minus y squared over 16, and instead of 16, I put 4 squared. So please notice, just like in the previous exercise that I did with 2 and 3, what you can do is just do square root and square. But notice the square root 16 is 4, so you put 4 squared. So you still do square root and square. And same with 4. If you do square root, it's 2 squared. So if you can extract, then you extract. If not, then just leave it as a square root. So to graph, I need to get a center. And notice that center will be the origin, right? 0, 0, because we don't subtract anything here. So it's x minus 0 and y minus 0. That's convenient. So if I want to graph it, I can put the 2 to the left and to the right. And then 4 up and down somehow. So I get this rectangle. So now, since we have a minus sign, since it's a hyperbola, then I put a box like that, because I'm after its diagonals. So I need to imagine this invisible lines, so-called asymptotes. So far, everything that I graphed has nothing to do with the actual hyperbola. We use this to help us to get the picture. So now x squared is positive. So this is going to be left and right. So this is one part of hyperbola, and here's the other part, left and right. Okay, something. So it goes along the asymptotes. That's the point. And I guess that's pretty much all. I was thinking about a little quiz for you for today, but I'm not gonna, of course, ask you to graph anything or do any completing squares. I'm gonna give you something pretty straightforward. I'm gonna create the exercise for you. And if you look at exercise 33, then what you can say is gonna be y squared negative. So it's top, bottom graph, again, because y squared is positive, so x squared is negative. So ask you if it's left, right, or top and the bottom. So left, right, so you could see right away in exercise 31, x squared is positive, so it's a left, right. Or for example, if you get 36, you see that x squared is positive, left, right. You can see in 32, x squared is negative, top and the bottom. Right? So for you, for a little quiz, can you tell me exercise 30, left, right, or top and the bottom? All you have to do is just put this in the chat. Remember, we already had one quiz in the Zoom chat. You put either top and the bottom or left and the right, and send it only to me, not to the whole class, please. And that'd be our quiz for today. So you don't graph this. The question is this hyperbola with x squared negative gonna be left, right, or top and the bottom? X squared here is negative. So look at this sign and then this side. Probably similar to number 33, right? So just left, right, or top and the bottom. Or if you don't know what it is, you can think about it and email me the answer later, today or tomorrow or whenever you'll be done with it. So just give it a little thought. And if you, for some reason, could not follow to what we just did, that's fine. No worries. I will email you a recording and you will be able to watch what we did, how we graph, and why top, bottom, or left, right hyperbolas appear. It all depends on the sign of x squared, right? And that'd be all for today.
It's
So
question 30, right, Professor?
yes, from hyperbola in exercise 30, just tell me if that's the graph of hyperbola, which is on the top and the bottom of the box, like here, or it is supposed to be put on the left and the right. And that'll be all for today. And thank you for coming and thank you for paying attention. And of course, that's good idea to redo the problem. Maybe the first problem that I did today was this completing the squares. And next time I'll do another one with completing the squares for you. So I hope by that time you'll be fine with it. So when we're gonna have a midterm exam, I will put completing the squares exercise there, either ellipse or hyperbola. We'll get closer to it. We'll discuss that. Now it's just a, second week of class. So we'll get.
Have a good day, Professor.
Thank you. Bye-bye.
So we just need to do 30, right?
Yeah, 30. Just say either on the top, on the bottom, or left, right. So you don't really have to do anything, but just put the answer in the chat.
Here.
By the way,
Top, bottom, or left, you said?
or left, right. Left,
Okay.
right looks like that, like 37. Left,
Okay.
Excuse me.
and top and the bottom looks like the other
Okay.
side.
Yes, got it. Thank you. Thank you.
Can you email the lecture recording?
Yeah, in a couple of hours, because it takes Zoom a while to process this into a nice recording file. So usually like takes an hour plus, sometimes an hour, sometimes 2 hours. So
Okay. Thank you.
Yeah.
Have a great day.
bye-bye.
All right, Professor, I sent you the answer.
Very good. Yeah, I get all these answers. In fact, this chat is recorded, so it's great that you put this in the chat.
All right. Have a good day then, Professor.
Bye-bye.
Bye-bye.